Okay, so can you tell me about yourself and about your current project?
Yeah, hi. So I have around 6 year of experience in software development, and I started my career at Verizon as a backend developer, and mainly working with Java and React. And there I focused on building and enhancing enterprise level applications. Then I moved to BL, so still on Java and React, but with bigger focus on the designing modules and improving system architecture. After that, I joined a retail project where I handled Java along with Docker and cloud technologies like AWS. So my major role was for the gathering requirements, designing solutions, developing both backend and front-end components, and handling migrations and even working on the deployment. And currently, I'm working on the modernization project. So there, taking the legacy application and upgrading it to a modern tech stacks Spring Boot and using microservices. And we also have to refactor the old code, and we have to introduce a modern frameworks and enhance the security and performance. So yeah, so it's been a great opportunity for me to work closely with cross-functional teams and ensure a smooth migration without disrupting business operations. So yeah, that's what is about me and my current project.
Okay, okay, so you have experience with Docker, AWS. Do you know front-end frameworks like AngularJS and all?
Yeah, I have worked with Angular also, and that's basically it's been a while, but with a short refresh, I can start working on it. Yeah,
Okay, what is the Java version you are currently using?
yeah. Mostly I'm using Java 8, and I have also explored with Java 17, but haven't used it much. And yeah, so that's what.
Okay, and what about the Spring Boot version?
Yeah, for Spring Boot, I have used 2.x.
Okay, how comfortable you are with Java 8 and what traditional practices would you avoid?
Yeah, I'm comfortable with Java 8, and I have been using it mostly in my projects. So things like streams, Lambda expression, method reference, and new datetime APIs. Uh, so those things I have been keep on using in my projects. So what practices I won't follow now whenever I write the Java code. So earlier we used to write like long anonymous inner classes and all right. So now instead of that we can write the simple like lambda so that can do the same job. So it is very much easy to read and understand by anyone. And I also avoid using raw types of non-generic collections since they can lead to runtime errors. So I am also careful not to mix too much business logic inside the loop when I can use the streams for cleaner and more maintainable code. So yeah, so I will extensively go and use the streams and all, and I will try to not write the boilerplate codes and easily like anyone can understand, and it is a kind of clear functional style of code it should be. And the for null pointer also, like earlier we used to write like null checks, right? Now we can use optional to avoid any kind of null pointer issue. Yeah, and for date time also, as I told, so the new date time API we can use wherever we are using dates. So yeah, so these are the changes usually I keep in mind whenever I go for the code. Yeah.
Okay, can you explain method overriding?
Yeah, overriding is when a child class provides a specific implementation for a method already defined in the parent class. So we also override when implementing interface methods with our own logic. So yeah, that's what is method overriding.
Okay, fine. So let's say we have two methods. One is public void get, and we have another method public int get, and it accepts int a as a parameter. So is it overridden or it is overloaded? Will it compile?
Yeah, so one is public void get and another one is public int get, and it also has the uh, parameter int a. So this is actually method overloading, not overriding, because it has the same name and it has different parameters. So different return types are fine here. So yes, it will compile, but it is like method overloading, not overriding. So it will be in the same class. So it will be in the same class. In that case, it is overloading.
Okay, now let's say we have public void get and we also have public int get. Okay, so what is it? It is overloading, overriding.
Okay, so we have a public void get and public int get. So here only the return type is different, but method is same, right?
Yes.
Yeah, so actually it won't compile. It will throw us the compile time error. So in this case, like the parameter list is exactly the same as the first method, like the get method. So only the return type is different. So Java basically does not allow two methods with the same name and parameter but different return types. So the compiler will throw an error here. So it is neither overloading or overriding.
Okay, what is encapsulation in real world programming?
Yeah, encapsulation is basically about keeping data and the methods that operate on the data bundle together inside a single unit. So typically in a class, so instead of having variables floating around everywhere, we can keep them private inside a class and expose them through the public methods. Like you can use the getters and setters inside that class. So that way we can control how the data is accessed or modified. So that makes the code like more safer and easier to maintain. And when we create an object using new, so the instance variable and the methods are tied to the specific object in the heap basically, and static members on the other hand are encapsulated at the class level. So basically they live in the method area. So also like kind of a stack memory. So it all depends on the JVM internals and are shared across all objects of that class. So in very short, encapsulation is all about the data hiding and control access, and while also we make the code like kind of more modular and easy readable. So that's what is all about the encapsulation in real world programming.
Okay, suppose we make everything as public in the class. So let's say we have a class bank account and it has one property called balance. So we say public double balance. Okay, and the getter and setter is anyway it is public, right? So is it still encapsulation?
Okay, so yeah, the technically the bundling of the data and methods in a class is still encapsulation, but without access control, it loses its main benefit actually. So whenever we are saying public, so easily someone from outside can change the those properties, right? So basically, data hiding we are not able to do. in this case. So if all members are public, any external code can directly modify them, so which can lead to inconsistent state. So it is bad way of encapsulation basically, but it will still be set the encapsulation, but it is not a good practice to do the encapsulation. So yeah.
Okay, fine. So what is abstraction?
Okay, so in Java, abstraction can be achieved using the abstract classes and interfaces. So interfaces are kind of 100% abstraction, and abstract classes are like kind of the partial abstraction, we can say. Abstraction is about just showing only what's necessary and hiding the details of how it is done. So basically it lets us to use something without having to understand all the steps happening inside. So for example, when we call any object dot method name, then we don't need to know the whatever the lines of codes inside that method. We just need to know what it does for us. Okay, so in Java, abstraction is not only about the abstract classes and interfaces. Even a regular class can hide the complexity by keeping the internal logic private and exposing only the methods we can actually need to use. So it can be achieved using two ways: one is the abstract and one is the interfaces. Yeah, so that's what is about the abstraction.
Okay, so how can you achieve abstraction without using abstract classes or interface? Do you know?
Yeah, so like even in concrete classes also we can hide internal logic by keeping the helper methods private and exposing only the high level public methods that the user needs. So for example, like service method might internally call the five private helper methods, but the caller only sees the single service method. So that is how we can achieve abstraction.
Okay, can you tell me one a small example where the abstract class and interface is not used, but it is still abstraction?
Yeah, so like for example, let's say we have any payment service, okay, and that payment service, let's say have like method, let's say public void process payment we have, and then again inside that we have multiple methods, let's say validate amount, connect to bank, transfer funds, and all are there. So now whenever we say someone like validate amount, okay, so in that inside that validate amount method itself, we can just write one small logic, like if amount is less than zero, then like just throw the exception like invalid amount, something like that. Okay, so that thing we can do, and this we can write inside the private method. Okay, so private void validate amount, and then we can just simply write our logic. So here anyway this logic is hidden from outside, and here we have not used any abstract class or interfaces, but it is still abstraction because we have hidden the main logic here. So yeah, so that is how we can do it.
Okay, why do we need interface when we have classes? Can you explain?
Yeah, interface basically lets us define a contract, we can say, like a set of methods. A class must be implemented without worrying about log, uh, without worrying about how those methods will be implemented. So that's what is interface basically. So one main reason we need them is to like just Java does not allow multiple inheritance in of classes, but it does allow a class to implement multiple interfaces. Okay, so basically that means that we can combine behavior from different sources without running into the diamond problem. So we can get it in languages with multiple class inheritance. Okay, so interface are also useful for writing flexible or and loosely coupled codes. So we can code to an interface, not a specific class. So basically that makes it easy to swap out implementation later without changing the code that depends on them. So yeah, so that is why we need interfaces.
Okay, so can interface have method implementations also?
Yeah, since Java 8 interfaces can have default and static methods with implementations. So since Java 9, they can also have private methods for internal reuse. So, but the core idea of an interface is like defining a contract. So that has not changed. But yeah, from Java 8 onwards, we can have.
Okay, so tell me one thing. If interface has default methods, okay, so isn't it just like an abstract class?
Uh, Not exactly. So abstract classes can have instance fields and constructors, and interfaces cannot have that. And a class can only extend one abstract class but can implement multiple interfaces. Okay, and also interface default methods are mainly for backward compatibility. So older code implementation, that interface does not break when new methods are added. So that's the major difference while using the interface and abstract classes. So older code implementing that interface does not break when new methods are added. So that's what is the like difference between interface and abstract classes.
Okay, can we create an object of an interface? Is it possible? Or anything similar we can do?
Uh, no, we can uh, not create the object of an interface, but similar means we can create an anonymous class or use a lambda expression. So like if we are using functional interface, so that we can do, but yeah, we cannot have the object of interface.
Okay, tell me one more thing. Why we use an interface instead of base classes? If I know there will be only one implementation always be there.
Yeah, see, even if we start with one implementation, so using an interface, it is kind of we can say foolproof or future-proof design. So that is what the main purpose of interface. So like there can be the chances that initially we have only one implementation, but in future it may go with the multiple implementation. Okay, so so if we are using interface in the beginning itself, so it won't be like painful when we have multiple implementations coming up in the future. So that is the whole idea of using this interface.
Okay, do you know any design patterns?
Yeah, I know design patterns like singleton, prototype, factory, abstract factory, builder. Yeah, so I know these design patterns.
Okay, can you explain abstract factory pattern?
Yeah, abstract factory pattern is like factory of factories. So instead of creating objects directly, we can use an abstract factory to get other factories, and each factory knows how to create related objects. So for example, let's say we have one abstract product interface. Let's say we have one chair and table interface. So chair has, let's say, void sit on, and table has void use, and then we have concrete products like let's say the modern class modern chair is there that implements chair, and class modern table is there that implements table. Okay, and there we have the implementation of the method like public void sit on, and we have the implementation and again public void use inside that modern table which implements table. Okay, Now again, let's say we have another chair that implements chair, and we have another table that implements table. So now whenever we say in the main method, like we can just say like furniture factory equal to, let's say, a new modern furniture factory, and again under that we have the create chair and create table factories. Okay, so we can just say that from that object factory dot create chair, and then we can get the chair object, and factory dot create table we can get the table object. So we have here, this is like how we have here factory of factories, so we can get the data out of it. So yeah.
Okay, tell me one thing. Can abstract factory be implemented without interfaces?
Yes, we can do that, but it's less flexible. So we can use abstract classes or even plain classes with configuration, but interfaces are more preferred because they keep the code loosely coupled. So that's the reason why we use interfaces.
Okay, so is there any way now abstract factories are being used or that can be used? Like any framework provides that?
Yeah, so like Spring framework does that automatically. So dependency injection frameworks like Spring that often replace the manual abstract factory uses. So instead of creating factories ourselves, we can let the dependency injection container provide the right product family at runtime. So that is done by Spring, yes.
Okay, good. Okay, what is the difference between hash map and concurrent hash map?
Yeah, hash map is not thread safe. So multiple threads writing the same uh, time can corrupt the data. And concurrent hash map is thread safe. So it uses the segment based locking on the bucket level locking. Like it uses segment based locking, so that is in the older than the Java 8 version, and bucket level locking from the Java 8 onwards. So whatever reads happens, it almost lock free, and writes are more efficient than a synchronized hash map. So also hash map allows null keys and multiple null values, while concurrent hash map does not allow null keys or values. So this is the difference between these two.
Okay, why doesn't concurrent hash map allows null keys and values? Any specific reason is there for that?
Yeah, for key, for example, null would cause ambiguity during the lookups. So whenever the lookup is going to happen, so that will create ambiguity. So is it a missing key or it is a key with null value? So that we cannot identify. And for values, why it does not allow null? Because null makes it harder to distinguish between no mapping and mapped to null without extra checks. So that is the reason why null is not allowed.
Okay, so what happens if two threads put values for the same key at same time?
Okay, so in multi-threading environment, if two keys are doing at the same time, so in that case, basically the operations are synchronized at the bucket level. So only one thread's value will be stored at the end. So it won't allow both of the threads to enter and do the modification. So I think it only the whichever comes the last, like suppose one thread comes and writes, and again the last one whichever thread comes and writes, so basically that data will be there.
Okay, let's say we have a scenario in Java 8 where we just say list of strings we have, okay, streaming the data, and at the same time we are trying to add some data into it in Java 8. So will it work or will it throw any exception?
Okay, so you mean we have a stream which has like A, B, C, D, E, or whatever the strings we have, and then we are trying to add while iteration we are trying to add, right?
Yes.
Yeah, so it won't let you add because it will throw concurrent modification exception. As I said earlier, whenever we have the array list or anything and we are trying to add at the same time while iterating, so it will throw the concurrent modification exception.
Okay, what is the difference between reduce and collect in streams?
Yeah, reduce is for combining elements into a single result using a accumulator function. So it is basically good for some product, mean, max, and all. And collect is like kind of more general, we can say. So it is for mutable reductions like building a list, map, or a string from the string stream elements. So that's what is the difference between these two.
Okay, how do you handle checked exceptions in streams? Can you do it first of all?
Yeah, actually, in streams, it does not allow directly to write a lambda that throws a checked exception because functional interfaces like uh, it don't declare the throws in their method signature. But if suppose if still if you want to do, then maybe we have to do inside the try catch. So let's say we have any like list of string, and then we are trying to stream over that, and then we can just say for each, and then each file as a lambda expression we can take as an input, and now here inside that we can write the try catch method. So that is how we can do it. And there is one more way in Java 9 plus. We can use files dot lines, so that we can use in a try with resource block, and we can keep the exceptions handling outside of the string, outside of the stream. So that is another way. So that is how we can do that.
Okay, let's say suppose if I ask you to create a Spring Boot project from scratch, how will you do it? Can you tell me all the steps?
Yeah, so first of all, I need to decide the Java version and Spring Boot version I will be using for it. So usually we take the latest stable ones unless the client has any restrictions like we have to use some specific version. So so first of all we can go to Spring initializer like start.spring.io, and we can give like what is the project type, like POM, it is Maven, Gradle. So based on that we can choose, and like Java and Spring Boot version, and then metadata we have to add project metadata, and then we have to add dependencies, like we have the option to add there like Spring Web and data JPA, Lombok. So those things we can add, even if we want actuator and all security, so that also we can add, and then we can generate and download the project. Then we can open it inside the Eclipse or IntelliJ, whatever IDE we are using, and then we can like just verify, like build that package, and we can create the structure now inside that project like controller, service repository, and beans, configuration classes. So all that we can create the package structure, and then we can run the application, and after that we can just simply test, maybe using the Postman or any other tool. We can just test at the any REST controller, write a small get endpoint like hello world or something, and if it is coming up means we are good to start now. So that is how in the beginning we do it.
Okay, what is the difference between component and bean at the rate of bean in Spring?
Yeah, add component that is placed on the class. So whatever the class we write on top of that we can place it, and Spring will automatically detect it during the component scanning. Whenever we use at the rate of component scan, any annotations like at the rate of Spring Boot application. So in that case, it will be automatically scanned and the bean of that class will be created. And then at the rate of bean basically means that it placed on the method inside the at the rate of configuration class basically. So we manually create and return the object in the method, and Spring registers that return value as a bean in the application context. So basically that will be on top of the method. Okay, this add rate of bean. So basically, and this is useful when we need to create beans of a third party classes and you cannot annotate with add component, and we want to fine grain controller over the instantiation logic. So that's what is the difference between these two. So add component is basically is automatic when works through the scanning, and add bean is like explicit, and we tell Spring that exactly how to create the bean. So that's the main difference between these two.
Okay, what is dependency injection in Spring and how it is implemented?
Yeah, there are three types of dependency injections. One is constructor, setter, and field injection. And constructor injection is mostly preferred. And basically, dependency injection auto wires our services internally. For example, if we want to use repository layer method, we can auto wire the classes and use the repository methods. So that's what is the dependency injection.
Okay, so when is constructor injection preferred over setter injection?
Yeah, constructor injection is preferred whenever the dependency is mandatory. So, for example, if our class cannot function without a certain dependency, using the constructor injection ensures it is the. So, we use constructor injection whenever the dependency is kind of mandatory. So if our class cannot function without a certain dependency, then using constructor injection ensures it's provided at the object creation time. And for immutability also, so constructor injected dependencies can be marked as final, so that makes the object immutable after the creation. And also it is better for testing and for the framework safety also we use that. Constructor injection is preferred for required dependencies, so it ensures that the object is in valid state, and it supports immutability, and it's suitable for the mandatory dependencies. And for setter injection, there is a risk that the object is created but the setter is never called, so it lives basically in the invalid state. That's what when we can use a constructor injection over the setter injection.
Okay, so what are Spring beans and how do they work?
Yeah, Spring Beans are basically the entity classes, and we can say so we create beans so that, for example, if we have a database, we can map the database columns with our Spring Boot application. So it's a good practice to do that so that our code is like optimized and automatic, like object mapping happens.
Okay, so do you know what is Spring Boot application internally consist of? So there are three another annotations.
Consists of add component scan, add configuration, and add enable auto configuration. So component scan will scan the components needed for our app, and enable auto configuration picks up the configurations we need like database connectivity and application properties, and add configuration is for explicitly defined configuration we want to use.
Have you ever connected multiple databases in Spring Boot at the same time?
Yeah, I have done that. So in a project, so where we need to read from one database and write to another. So for that, first of all, we define a separate data source configuration. So either in application.yaml or properties file, we can create a separate prefix for each databases. Like for example, let's say one is the MySQL, another is the let's say PostgreSQL. So we can just say spring.dataset.db1, then its your URL, username, password we can give there. And similarly for db2 also we can give its URL, username, password. And then we can create separate data source beans, so in two different configuration classes. So each we can mark with primary for the main DB and without it the for the second databases. So that after that we can set up entity manager factory and transaction manager for each. So like this way Spring will know that which data source to use in which repository. And then we can use enable JPA repositories with base packages and entity manager factory reference. So that basically tells the Spring which repositories should use which DB. So that way we can do it. So for DB configuration, so we have to write both of the configurations. We can use like add configuration annotation and add enable JPA repositories as I told, and then we can also give the base package name and the entity manager reference and the transaction manager reference we can give. So once we have both of the configurations ready, we are good to start with. So based on the whatever repository we are using, it will fetch the that specific database.
Okay, can you tell me how the singleton design pattern is related to database connections?
Yeah, the singleton pattern ensures that only one instance of a class exists in the entire application and provides a global access point to it. So in the context of database connection, so database connections are expensive to create and maintain. So if every class in our application created its own connection, so then we will waste the resource and possibly hit the database maximum connection limit. So a singleton ensures that a single shared connection manager or connection pool used across the application. So that's what is the singleton. So in very short, so every database connection in singleton design, so every caller gets the same DB connection irrespective of from where it is being called in the project.
Okay, so have you worked with at the rate of transactional notation?
Yeah, if a process fails midway, then the whole thing should roll back. So we use at the rate of transactional. So suppose any insertion or something we are performing, so and that insertion fails, so or maybe one or two would have succeeded, but it will roll back if it under the transactional.
Okay, let's say if we put at the rate of transactional on both classes and methods, then what will happen?
If we put a transactional on class, then it becomes the default for all public methods in that class. And if a method also has its own add transactional, the method level annotation overrides the class level set.
Okay, let's say if a remote service fails and you need to roll back, okay, then how would you handle it?
Yeah, we can use compensating transactions or a distributed transactions pattern like a saga design pattern. So that way we can handle it.
Okay, so in microservices, what happens if one microservices in a chain fails?
If that happens, then we can use circuit breaker pattern like we have resilience 4J histories. So it can be used to stop the cascading failures, and we can implement also fallback methods or default responses. So basically we can just write the default method implementation, like in case of failure what can be done.
Okay, can you tell me in very short what is the difference between API gateway and service registry?
Yes, service registry is like Eureka, Zookeeper and all. So it keeps track of service instances and their locations, and API gateway is a single entry point for request and handling routing, authentication, rate limiting and all. So we have Joule, Spring Cloud Gateway. So those are the API gateways.
And how do you test your microservices?
Yeah, we are testing using unit test for the service logic, and we are doing contract testing like packed to ensure API compatibility. And then we are also doing the integration testing with a test environment. So yeah, that is how we are doing the testing.
Okay, what are actuators in Spring Boot?
Yeah, Spring Boot actuators are a set of production ready features that let us monitor and manage our application. So they expose REST endpoints and give us information like application health, metrics, environment properties, and all. So basically, they help in detecting the issues early and tracking the app performance in real time.
Okay, can you tell some endpoints of it?
Yeah, we have actuator health, metrics, info, and all.
Okay, and what does this matrix do?
Matrix shows the performance metrics like JVM, memory, CPU usage, request count, and all. So that is what is the use of matrix.
Okay, suppose I want to enable all actuator points. So what do you do for that?
Okay, so basically by default, only few endpoints like health and info are exposed over HTTP. If we want to expose all endpoints, then we can say like exposure dot include equal to a star. So whenever we say star, so it includes all. But usually in production, we don't expose all, and and we should only expose what's needed and secure with the authentication.
Okay, let's say at any point of time you see actuator health endpoint showing as down. Okay, so it is not up. So how do you debug?
Okay, so in that case, first of all, I will check if it is a dependency issue. So DB, message broker, or any external services, and then we can verify custom health indicators. So maybe one of them is reporting down, so that we can check, and then we can run actuator health and then details equal to true to see which component has failed. So we can follow these steps to make sure, I mean, why it is down.
Okay, have you ever worked with Spring Data JPA? And can you tell me the advantages over a standard JPA?
Yeah, Spring Data JPA is a layer on top of the standard JPA itself, and that reduces the boilerplate codes. So it gives us the ready to use CRUD operations like save, find all, delete by ID, etc. without using SQL or JPQL for common operations. And then it supports the query derivations. So we can use define a method like find by email, and it will generate the query automatically. Okay, so we don't have to write any query for find by email if suppose we have a email property in the bean, so we don't have to do that manually. Okay, and it also integrates with Spring Boot. If we get features like pagination, sorting, and auditing easily, we can do. So those extra functionalities we get using Spring Data JPA.
Okay, so in your code, do you prefer custom queries or inbuilt methods?
Yeah, use inbuilt methods when ever we have to use the simple lookups like find by id, find by name containing, and all. So in that case we can use simple lookups, but custom queries we can write using add the rate of query, and then we can write the query. So whenever suppose we need to use some joins or complex conditions or projections, then we can go for the custom queries.
Okay, can you tell me any limitation is there of using Spring repositories?
Limitation, yeah, for example, method name queries can get too long for complex queries if we are writing, and there is no fine control over generated SQL unless we drop to add the rate of query. And also for bulk operations, inbuilt methods can be slow, so we can better use at the rate of modifying queries. So yeah.
Okay, so for a long batch operation, how do you manage transactions for performance and consistency?
Yeah, in case of a long batch, we can break the batches into chunks and commit after each chunk. So, like that basically avoids holding the logs for too long. So we can use entity manager dot clear periodically to free up the memory. So, for example, if we have like let's say we can apply a for loop, and like in the we have, let's say, like millions of records are there, so we can just say repository dot save, and we can just say I percent 50 equal to 0. So every 50 chunks of records we can push the data, and we can disable the automatic flushing, and we can control it manually, so that we can do to whenever we have the batch operations.